Today we are going to discuss about variable derivation, which is very important concept in predictive analytics. Analytics is very important, playing a very predominant role in our data science. And in the area of this analytics, variable derivation has a very important role. It's nothing but it's a technique used to create variables from the existing one to enhance analysis, modeling, or data understanding. These methods are common in data science, machine learning, and statistics and related fields. Below, it's nothing where any researcher needs any information, and that information is available in a different form, and the researcher needs in the other form. It can be transformed based on the requirement of the researcher. That is what we are going to discuss today. How, in what all form it can be transferred, that is, can be derived. The first important thing is a transformation based on derivation, that is mathematical transformations, applying like logarithms, square roots, exponential, polynomial transformation to the existing variables to normalize the data or capture the non-linear relation and to make the relationship more linear. Example, income with the different log values can be converted to the normal values so as to remove the skewness in the data and to convert the data into the normal form as required by the researcher. Next method is scaling and standardization method. Here the common scales such as z-score, minimum maximum scaling can be used. Normally it is here the standardized mean value 0 and standardization deviation will be 1 under this method. So based on that ratio, the data has to be collected and can be converted using z-scores and minimum and maximum scaling methods. Next important method under transformation based derivation is binning method, converting the continuous variables into categorical ones by grouping them into bins. Example, the age can be converted as 0 to 18 years or 19 to 30 years, 10 to 20 years, 30 to 40 years. Likewise, it can be binned. Okay, the relationship can be binned in such a way and the data can be converted. Next method is ratio or proportion method. Here, the ratios or percentages can be derived from two variables. So as to, these are all the methods where as per the requirement of the researcher, the methods can be adopted accordingly. Next method we are going to discuss is derivation of variable is feature engineering. It's nothing but using some high configured methodology to convert the data available. In this terms, it is first method is interaction terms, combining variables to meet the requirement, that is to capture the joint effect. If there is any relationship between two variables that can be related, for example, age and income, that can be related by using modeling tools. Next is polynomial features like higher order terms can be derived from one value to other value and to remove the non-linear effects and to make the value more readable. Next, aggregation methods, nothing but just like addition, this summarizing data groups into mean, sum, count, all adding together or finding out the average purchase or average income of people. There all this aggregation method can be used. Next important method is time-based features. The features are the correct feature of any data that is needed for the study has to be found out based upon the features. For example, here it is given as day, month, hour, time differences, etc. Likewise, various informations can be derived so as to find out which is most important or relevant. Based upon the time based features, this method can be used. Next important type of data variable derivation is encoding categorical variables. Categorical variables is age, any color, school, where the school the person is studying, which college he is studying, which city the person is still living, what is the average sales, etc. Like, so one first method is one hot coding method. Here binary values for each categories will be found out. That is converting color into red from one color to another. That is, next method is label coding, assigning numerical values to the categories. For example, high school, college, like means high school value 1 can be given for college, 2 can be given for graduate, 3 can be given. That is actually giving some label to the features of the data. Next, target encoding. It's nothing but replace the categories with the mean of target variables for the categories. That is only by finding out the average of any aspect, the mean value can be given. For the mean and average almost the same. So based on that, the mean value can be taken for encoding the data and to understanding the meaning of the variable. So next is nothing but dimensionality reduction based derivation. Here PCA, this is a principal component analysis, derive new variable as a principal component. Any data for that matter, any variable for that matter will have some principal component in it. So that principal component has to be identified, and that principal component must be highlighted among the viewers, so that based on that better derivations can be given on the based upon the requirement of the scenario. Next, clustering based features. It's nothing but dividing or forming groups of the given data. This is done by k-means clustering of a customer data, which we'll discuss in the meaning of k-means we'll discuss in one more class. Who here the cluster based features plays a very important role. Next important type of variable derivation, domain specific derivation. Domain specific is nothing but creating binary value based upon condition. It's nothing but which is higher, which is that is indicator or flags, giving some indications or flags to the given situation or the variables. Based on that also, this the value can be derived. Text based features, okay, exact feature from the text like word counts, sentiment scores, anything like that, it can be given based upon the text based, any text or for the identification will be given to the particular scenario that can be identified, and based on that data can be derived. Geospatial features like area, distance, spatial distance between the customer relation and store, hospital and the patient's residence, like government offices and the where the people are staying. All these places, this type of thing can be, this type of variable derivation can be used. Automated feature generation. The use of such feature tools or automated machine learning platforms can just simply by giving the data into the machine, you can generate the required data. Okay, based on that also we can derive informations according to the need of the researcher. So with this I conclude my topic on variable derivation. So any data that is given can be derived as per the requirement of the research.